I'm Emma Johnston. I'm 30 years old and I'm an ecotoxicologist. An ecotoxicologist looks at how pollutants in systems might poison animals and plants. There's a lot of marine organisms, and I'm talking about sponges and sea squirts, lots of gorgeous little animals that are living in really polluted environments around Australia. And in order to study them, we need to actually simulate those environments and try and work out what it is that's causing the damage. How I fell into marine pollution research is a really interesting story. I grew up next to the ocean, for example, so I was always jumping in, I was snorkeling and sailing from a very early age, and I think that meant that I always had that interest in the animals and the plants that were under the water. But then when I started my university degree, I did a very broad science degree. I actually wanted to be a science journalist to begin with. And then I was inspired by some excellent marine ecologists at the university that I was studying at, and they really got me hooked on doing research and getting really in-depth to a particular topic. Combine that with a interest in environmental impacts, and there you have it, an environmental ecotoxicologist. If you want to be a marine scientist, there's a couple of things you need to do. First of all, get out there, get on the water, get in the water, get under the water. That's the fun part, but it really teaches you a lot about marine animals and plants. But secondly, you have to do a broad science degree, then you have to focus in on your particular interest area. That might be chemistry, it might be subcellular organismal biology, who knows? You might be doing something very complicated, but it will take you and lead you into a career in marine research. So we're using this site here, which is right near to the opening of Botany Bay, because it is pristine in terms of water quality. So we're looking at the ideal situation and mimicking what happens in the more polluted sites that you might find further up the bay. I love my job. It's so diverse. I get to come out on the end of a pier and I get to jump into water and dive and snorkel. And then I also get a really diverse amount of work back in the lab, so microscope work, but also lots of time spent on the computer analysing, so a bit of mathematics, a bit of going to the hardware store, and a lot of reading, a lot of library research. So it's really diverse, and that's what makes it fun. So in this experiment, these guys here and here are the lucky ones. They're growing up without any pollution events, pristine environment. And they're our controls so that we can see what would normally happen. And we're going to bring them back into the lab after a few more weeks, count all the animals, work out who's alive and who's dead and how the system's been changed by the pollution events. Well, what we're finding is that really quick pollution events, just come and go in a day, are having a major impact on the marine organisms, creating a lot of space in the system. A lot of the time, it's invasive species that are getting in there and taking up this new space. One of the most exciting adventures I've undertaken as a marine researcher is to go down to Antarctica and to dive underneath the ice sheets there. As an academic, I have a really wide range of duties. One part of my work is research, and another big part of my work is teaching. I also have some administrative responsibilities as well. In the scheme of things, I think all marine research is important because we know so little about the vast expanses of the ocean. Ocean is 4 kilometres deep on average. So I'm hedging my bets here, but all marine research is important. The sorts of research I do can really help managers, environmental scientists and government people protect marine systems, and that really helps me stay motivated.